and we were discussing a machine where on the stator there is a balanced 3-phase winding, on the rotor there is a balanced 3-phase winding, and I will connect the stator with a supply R s, Y s and B s. Stator is of course stationary and I will energize it. There will be a resultant rotating field, and on the rotor also I have a winding, balanced 3-phase winding having N2 turns per phase, and suppose the rotor is locked and it is not allowed to move, then what is going to happen? This rotating field is going to induce a voltage on the stator coils as well as on the rotor coils. That is what I told, E 1 will be there and as well as E 2 will be there. Now, if somebody says rotor is also locked like stator, stator's freedom are stolen because they are grounded, they are not allowed to move, then what happens is neither of them is allowed to move, but you apply a 3-phase voltage on the stator, then a rotating magnetic field results, there will be induced voltage, but the rotor may be locked either in this position or in this position when the R phase axis are coinciding with the R phase axis of E phase, etc. And we explained that if it is shifted R phase by some angle theta, the induced voltage in this will be also shifted, and magnitude of that voltage will depend upon N 2 by N 1, and so I can also manipulate the voltage and as well as of course, frequency remains same, because P n s by 2, n s is the relative speed for both stator conductors and also for both rotor conductors. So, this was used earlier and called phase shifter. Okay. So, this is the thing, for various purposes it was used. Okay. In some laboratories it is still, in some laboratories it is still available, you see, measurement lab, this that. Achha, now, what I am going to tell you, I will now remove this restriction that rotor is locked. Okay. Then what is going to happen? So, it is now like this, rotor, now rotor which houses a balanced 3-phase winding is free to rotate. No phase shifter thing I do not want to make. So, this is your stator supply, R 1, Y 1 and B 1, and this is your rotor supply, rotor coils, which initially I do not know, they may be anywhere, R 2, Y 2 and say these are 120 degree, please forgive me, this is 120 degree also, R 2, Y 2 and B 2. And these are the rotor terminals. Okay. I was calling it RR, YR and BR. Okay. Now, in this case you see this is very interesting, you energize this with a 3-phase coil. Suppose you have a switch here with the supply. Three-phase supply, balanced. Close this switch and rotor is suppose open circuited, close the switch and result is known. There will be a B s and it moves in this direction, phase sequence is R I B, it moves with N s, mechanical speed. And rotor coils are open circuited like this, and this flux also will cut this rotor phases, there will be induced voltage. Acha, under this condition and with nothing connected like this, suppose there is a switch and I will suppose I will keep this switch, this S is open initially. Will there be voltage across the machine terminals? If you connect a voltmeter, yes, because there will be E 2 per phase induced of same frequency and root 3 into E 2 will come here, this voltmeter will read, and this will be a balanced 3 phase voltage, okay, because the windings are spatially 120-degree electrical apart, phase windings. Therefore, although there will be AC voltages induced, but no current flows. Can rotor produce a magnetic field? No. Coil must carry current to produce its own magnetic field, and only magnetic field present in the machine is Bs. Okay. And Bs just it is like this, there is a suppose magnetic field is at this point, these are stator coils, they are energized Bs and rotor is there, but no current is flowing. So, Bs is suppose like this, at this time it is vertical. Acha, if it is vertical, this do not forget that these are the lines of forces at that instant. Acha, what is what? This becomes, it is a two pole structure I have taken. So, this will become stator south pole and lines of forces are coming out from this surface. So, this has become Ns, half of the stator is Ss, Ns like this. And while completing its path, I mean it will complete here, it will not go to here, just that vector I was showing, vector arrow is along the direction of lines of force inside the machine. So, it will go like this. So, half of this will become south pole and half is north pole, this we have seen extensively. But you see rotor coils are not carrying current, no doubt, but rotor this one lines of force are emanating because of the stator field, it becomes your some Nr induced and this becomes Sr, is not. That is this is the stator iron, what I am telling, this is only rotor iron, rotor coils are not carrying current. The moment you tell there are lines of forces moving like this, oh rotor this surface must have become a north pole induced, like a soft iron piece kept in a beside a permanent magnet, it becomes a induced magnet. But nonetheless note that this is Nr because lines of force from this surface of the rotor coming out and lines of force are entering. So, this is Sr, these things are there, but that is the rotor poles are also created when rotor is not carrying any current, no doubt, because of these induced poles in the rotor because of stator poles. But one interesting thing you see, this Nr and Sr, can Ss and Nr interact and give you torque? No, because their line of action is same. There must be some shifted thing, if this is Ss, this is Ns, your Nr, Sr must be shifted. In one of the lectures I told you that, then only it will experience, rotor will experience a torque. Otherwise, this induced pole is doing nothing, it cannot produce at least torque. Is that clear? That is very interesting, although there will be induced poles, but there is no angle between these two to give you a force or torque developed in the machine. So, that will be there. Now, so with this switch open, only thing what happens is this, because of this B s there will be induced voltage here, and what will be the line to line voltage? Root 3 into E 1, and it balances the supply voltage if you neglect stator resistance and leakage reactance. If you neglect, this applied voltage will be balanced by the induced voltage E 1 here. Okay. Similarly, in the rotor circuit there will be E 2 induced voltage per phase, root 3 2 will come here, a balanced 3 phase voltage is available across the rotor terminals. Okay. That will be the thing. Mind you, the induced voltage in the rotor is balanced 3 phase. Now, let us imagine I have closed this switch. I have closed this switch. If you close this switch, there was balanced 3 phase voltages. Therefore, we expect, and suppose it is shorted, these windings are balanced, all the impedances whatever it is on the rotor side they are equal, and therefore, it is expected this E 2 will drive some current in the IRR, IYR and IBR, is not? They are expected to deliver current, but nonetheless these currents will be balanced 3 phase currents, because it is after all in the rotor you have generated balanced 3 phase voltage and you have closed the circuit. Impedance in each phase is its own impedance, that is how current will circulate, and therefore, balanced 3 phase current will flow also in the rotor coils. If that be the case, then we know what is going to happen. Rotor coils carrying balanced 3 phase currents. Therefore, rotor 2 will develop a rotating magnetic field, say B r. Also in the direction from R r to Y r to B r, from leading to lagging phases. And what is the speed of this rotating magnetic field? Speed will be once again, if F r is the frequency of the rotor, 2 F r by P will be the speed of the rotating field. Let us imagine that initially the rotor was stationary when I close this switch. Mind you, speed cannot change instantaneously, because it has got an inertia. To change speed instantaneously of a mass or a inertia, you require infinite force. It is forbidden. That is the Newton's law. It cannot, speed cannot change in no time. Speed cannot have a step jump. It was 0, in no time it has become 50 meter per second. No, that is not possible. Then acceleration must be infinite. So, only thing it may approach to that condition if you have applied infinite force. That is not we are doing. So, the rotor has got a finite inertia. When it was not closed, speed of the rotor was 0, at t less than 0, speed was 0, and at t equal to 0 I have closed the switch. At t greater just equal to 0 plus, what I am telling, rotor speed must be 0, speed cannot change. Let the rotor carry current, whatever it does, but speed instantaneously cannot change. It forbids Newton's laws of motion. Okay? Speed cannot change instantaneously. Therefore, at t less than 0, Nr was 0, frequency of the rotor was f, supply frequency, we have seen a little bit earlier in the last class. So, frequency of the rotor current was F. At t equal to 0 plus, Nr is once again 0, still 0. Therefore, frequency of the rotor current at t equal to 0 plus is also supply frequency. It has not changed. Therefore, after you have closed the switch, I find that stator coils are supplied by a frequency f, rotor induced voltage, rotor has not yet started moving, speed cannot change instantaneously, although current will flow in the circuit. Therefore, frequency of that current will be f. Therefore, let us concentrate at t equal to 0 plus, what is the scenario? T equal to 0 plus, the scenario is there is a stator field, I will just draw this, it was moving with ns and the rotor frequency of rotor currents is also f and it will produce therefore, a rotating magnetic field, which is suppose I say I do not know where it is positioned, but I am pretty sure about this thing. There will be another rotating field now coming into picture B r say, and this also will move with what speed? Ns was equal to 2 f by p and B r, what is the frequency of this current? F, it will also move 2 f by p. In the same direction. The same direction I will further discuss, but it is not difficult to understand why it should rotate in the same direction. I will right now tell, but what happens is this: at t equal to 0 plus, I note that there is a B s, there is also B r, two fields are there and both of them are rotating with same N s. Therefore, a stationary observer will conclude the angle between them, although they are rotating, but angle will remain fixed in space. And therefore, see, without doing any maths, we are trying to physically understand, okay, can we understand what is going to happen? That is my intention is. So, at t equal to 0 plus, there is a stator field of supply frequency f, electrical speed is f, rotor also the same speed. Mind you, the number of poles of stator and rotor windings must be same, because we know that you cannot have a machine, you have wound the stator for 4 poles and rotor you have wound for 2 poles, it is not going to work, that we have seen earlier. So, some basic conditions to be fulfilled by for the torque production is that the number of stator poles and number of rotor poles must be same. If the stator you have wound for 4 poles, rotor is to be also wound for 4 poles. Therefore, at t equal to 0 plus, we find two fields are there now. Here also, when the rotor was opened, as I told you, there were 2 poles there, even if rotor was not carrying current, there were induced pole on the rotor, but this B s and this so called induced rotor poles, they will be along the same line, they cannot produce any torque. Perhaps in this case, when you close the switch, there will be a rotating field produced by rotor and frequency of the rotor current at t equal to 0 plus is also f, and it is f, the frequency of the balanced 3 phase current, which decides the speed of this field. And with respect to whom? With respect to the structure. What is the structure now? Rotor, but rotor is not moving at t equal to 0 plus. Therefore, a stationary observer will say both the stator field are there, rotor field are there, they are moving with same speed, and therefore, it is expected it will produce a torque and machine will start moving. Now, just physically to tell in which direction rotor will start moving. The Lenge's law tells us that the induced voltage or induced current in a coils will be such that it will try to oppose the very cause for which it is due. What is the reason for current in the rotor conductor's air? It is because of the induced voltage, and induced voltage, as we have seen, depends upon the relative speed Ns and Nr, which was equal to Ns at the instant we are considering. That was the cause of the induced voltage. In simple terms, because there is a relative speed, that is why there is an induced voltage in the rotor coils, and because of that induced voltage the current is flowing. Now, the question is, there are two options on the rotor. We have now understood, okay, rotor may rotate because there is stator field separately created Br, rotor fields separately created. But the question is, in which direction it will move? Either it will move in the same direction as that of Bs in the clockwise direction, or in the opposite direction. Which one do you think it will move, so that induced voltage becomes lesser and lesser, because that is the cause. So, cause it should start moving in such a direction such that the relative velocity decreases with time, then only Lenge's law will be satisfied. Of course, in later lecture we will apply left hand rule and decide about the direction of rotation, that is there. But you also start thinking in this way that okay, there is a stator field, there is a rotor field, at t equal to 0 plus they are moving at same speed. So, it satisfies that condition, the angle between these two fields perhaps is going to remain same at least at t equal to 0 plus, and therefore, we expect some torque is developed, and the question is in which direction, clockwise or anti-clockwise. It is decided by in which direction stator field is moving. It is moving in the clockwise direction, and you may be rest assured that rotor will start moving in the clockwise direction as well. That is the important and interesting part. Okay. Now, this is at t equal to 0 plus. So, we have now understood there will be stator field, there will be rotor field, and hopefully, these Bs and Br are not along the same line. We will examine those things, but it is likely they will have some angle separation between them, and that will cause rotation and rotor will start moving. And rotor will start move. So, some electromagnetic torque is developed and that is causing acceleration. Now, after t equal to 0 plus goes, machine will slowly pick up speed. Now, I want to examine, okay, rotor will start moving. Now, the question is, it will speed up 0 rpm it will be 5 rpm, 10 rpm, most probably that way speed will go up, and at what rate it will go up, it depends upon its inertia. If it is a very large motor, it will slowly move up. If it is a small motor, it will very quickly pick up. Those things are there. Now, the question is, So rotor will start moving. Let us argue like this. I will not draw all this detailed thing now. You have now understood. This is Bs Ns, and this Ns is 2 F by P, so much RPS. And here is now rotor. Rotor I will simply draw like this. So rotor coils are there. And we have now learned, if rotor has to rotate, it has to rotate in the same direction. Rotor speed, all are mechanical speed, mechanical. This is also mechanical. It cannot rotate in the opposite direction, because then it will violate Lenge's law. Relative speed must go on decreasing. So the induced voltage in the rotor E 1 we have written several times. Nonetheless, let me repeat that it is P n s by 2 flux per pole K W 1 N 1. E 2 will be root 2 pi P n s minus n r. Suppose rotor is rotating at some speed in the same direction. So, it must be then this pi K W 2 N 2. This is the rotor speed, not rotor field speed, rotor speed. Nr is mechanical speed. You connect a tachometer, whatever reading it shows, it will be like this. So, there is now Ns minus Nr, and Nr is going on moving. Now, the question is that T 0 plus business has gone. Now, sufficient time has elapsed, rotor is rotating, stator supply you have given, Bs is there. Now, the question is, what is the frequency of the rotor current? Because it is the frequency of the rotor current that will decide what will be the speed of the rotating field. So long Ns minus Nr not equal to 0, there will be rotor induced voltage, rotor voltage will be there, as well as rotor current will be there, because rotor current will be also present, because I have kept the switch closed, done nothing else. Therefore, both these things will be present, and I know if rotor current is present, rotor will produce a rotating magnetic field. What will be the speed of that field? It depends upon the frequency of the rotor current. What is the frequency of the rotor voltage and rotor current? It will be P by 2 Ns minus Nr. This is the frequency of rotor voltage or current. Anyway, we will continue this in the next lecture. Thank you.